So hi everyone, this is the webinar rules and expectations. It's a 20-minute presentation. Please mute your microphones when not speaking. Video is not necessary or required. You may ask questions anytime in the chat room, either during the presentation or following. Following the presentation, you may ask questions by raising your hand and turning on your mic, or you can use the chat room. The webinar will be recorded and be posted online. Announcement: Saturday webinar at noon, July 4th, 2020 will be our Student STEM Ambassador Skylar's presentation on supercooling experiment. And now we'll start our presentation. So today we'll talk about the fact check challenge, run some tests to see if Coke is good at cleaning dirty pennies. Can anything else clean a penny? The science that's really behind this reaction is the US 1-cent coin is often called the penny. A copper oxide is on the surface of the pennies. Phosphoric carbonic acid in Coke, and acetic acid in vinegar, citric acid in orange juice. Copper oxide is not soluble in water by itself, but copper oxide is soluble in acids. Vinegar is mostly water, but a small percent of it is acetic acid. This is phosphoric acid. It is a weak acid with the chemical formula showing on the screen. It is food additive, and a lot of soft drinks have phosphoric acid in it, such as Coke. Acetic acid is in the vinegar. Vinegar is mostly water, but has a 4% of acetic acid. Citric acid is a weak acid and occurs naturally in citrus fruits, such as lemons and oranges. And table salt is a sodium chloride. Hypothesis: vinegar and salt solution will give the best result because the acetic acid and salt both react with copper oxide. Salt added in the vinegar solution speeds up the process. Variables. Possible independent variables: how dirty the pennies are, amount of solution, and the soaking time. Independent variables we're interested in is soaking time, type of acids. Dependent variable is cleanliness, and control variable is amount of solution, soaking time, and same dirtiness of pennies. Materials: 1/4 cup of Coke, 1/4 cup of orange juice, 1½ cup of vinegar, 1½ dish detergent, 1 teaspoon of table salt, old pennies, 7 disposable cups, and Arrowhead spring water. Procedures: find old pennies, and next place 1 penny into each disposable cup. Pour in each solution in each cup, and set the timer for 50 minutes. Get all pennies out and rinse under cold tap water and observe cleaning effects. If they're still dirty, put back in each disposable cup and set the timer for another 50 minutes. Rinse again and observe again. And we can repeat that again. And this is the 7 old pennies that I use and all the other materials that I used. And penny 1 was used in Diet Coke. It was manufactured in the year of 1964. It has greenish and reddish stuff on the surface of it. Penny 2 was in water and salt solution. Manufactured in the year of 1962, has black stains on the surface. Penny 3 was in vinegar. It's manufactured 1972 and it has reddish stuff on the surface. Penny 4 was in a vinegar and salt solution. It was manufactured in the year of 1977 and it has greenish stuff on it. Penny 5 was in a dish detergent solution manufactured in the year of 1984 and it has greenish stuff on it too. Penny 6 was in a dish detergent and salt solution. It was manufactured in 1992, and it also has greenish stuff on the surface. Penny 7 is in the orange juice and manufactured in the year of 1998, and it has few black dots on it. This is the result of the penny after 50 minutes in the Diet Coke. The result after 50 minutes in the vinegar. The result in the vinegar and salt solution. The result after 50 minutes in orange juice. The result after 50 minutes in water and salt solution. Result after 50 minutes in the dish detergent solution. Result after 50 minutes in the dish detergent with salt solution. And this figure shows that the cleanless is 7, which is vinegar with salt solution. It's the cleanless after 50 minutes. And orange juice has only 1, which is the dirtiest out of the 7. Results. This experiment shows that vinegar and salt solution works best for cleaning the dirty penny. Diet Coke seems not working the best, maybe because the carbon dioxide escapes when in the air. Orange juice might take a longer time to work. This experiment shows that the acetic acid in the vinegar break the copper oxide free from the penny. Acetic acid alone does not clean as well as acid and salt. It appears that salt breaks down the free chlorine ions into the solution. The chlorine ions bond with copper in the solution, forming some sort of copper chloride, allowing the acid to break more of the copper oxide free from the coins. Thus, salt added in the vinegar speeds up the process. Conclusions. The result of the experiment shows that Coke might not be the best in cleaning pennies, although the internet has been echoing the claim Coke is best at cleaning pennies. Vinegar and salt clearly does a way better job than Coke in this experiment. More investigations in the future. Explore pH in different types of acids. Compare different kinds of carbonated drinks. Find the relationship between the soaking time and cleanliness. Find out if other amounts of salt make a difference. This is the end of my presentation.